In today's video, we're going to talk about how to describe the end behavior for a function. So your teacher might give you something like this and ask you to describe the end behavior. Honestly, I think the trickiest part of this whole thing is really just writing the correct notation at the end for your answer. Okay, so there's just a few things I want you to remember as we follow along, and you probably already know them. Okay, that this is your left and this is your right. That this is the x-axis and this side is the negative x values, this side is the positive x values, and that for y you can also think of it as f of x. Okay, so if you take a look at this chart right here, it'd be really helpful to memorize these 4 types of graphs. So I have it broken down like this. On the top, you'll have, anytime you have an x squared, x to the 4th, or negative x squared or negative x to the 4th, as long as you have an even exponent, you're going to have these 2 options for your end behavior. And then if you have an odd exponent like x cubed or x to the 5th, or negative x cubed or negative x to the 5th, you're going to have these 2 options for your end behavior. So if there's no negative in front of the x squared or x to the 4th, it's going to go up like that. And then if there is a negative in front of your x squared or x to the 4th term, then then the function's going to point down like that. And then if the function has an x cubed or x to the 5th or x to the 7th, it's going to go like that. And then if you have a negative x in front of the x cubed or x to the 5th, it's going to point down like that. So in order to describe the end behavior, you're going to take a look at your function and find the leading coefficient. So look at the term that has the highest exponent. That would be this one. And you kind of just ignore the other terms. So it says negative 5x to the 4th. So because it's x to the 4th, that means it has to be one of these. It's an even exponent. And because there's a negative 5 in front of it, it must be this graph, like right here. So if I take a look at this graph, basically the end behavior is that it's pointing down on both the left and the right side. That doesn't mean that this is the exact shape of this graph. I'm really just looking at the end behavior. The graph could be more like an M or an upside down W shape, but I'm only concerned about the end behavior. So you're going to describe what's happening on the left side of the graph and on the right side of the graph. So on the left side of the graph, this is as x is approaching negative infinity, and then on the right side of the graph, this is what's happening as x approaches positive infinity. Okay, so I could just simply just say that on the left, the function is decreasing because it's pointing down. And I could also say just simply on the right, the function is also decreasing because it's pointing down. But, so this is what I was talking about with the notation. Usually when you write the answer, you're not going to just write left decreasing, right decreasing. You're going to write what's happening as x approaches negative infinity and what's happening as x approaches positive infinity. So again, that has to do with what's happening on the left side as x is approaching negative infinity and what's happening on the right side as x approaches positive infinity. And then because we know it's decreasing, instead of just writing decreasing, you're going to write it as f of x, which is the function, approaches negative infinity. F of x approaches negative infinity. because it's decreasing on the left and it's decreasing on the right. And one last step is that usually in the textbook it will have these two flipped. So what you're going to actually end up writing is f of x approaches negative infinity as x approaches a positive infinity. Then same with the left, you're actually going to end up writing f of x approaches negative infinity as x approaches negative infinity. So if you can just memorize what the shapes of the graphs are, what the end behavior looks like, then all it is a matter of writing down and describing what it looks like in terms of f of x and x. So if you get a function that looks like this, again, you're going to look for the leading term. So that would be this one because it has the highest exponent, x to the fifth. And if you take a look at our chart, because it's an odd exponent right there, we know it's one of these two, and it has a positive 9 as the leading coefficient, so it's going to basically have this shape right here. So it's going to look something like this. And if I were just to ask you to describe what it looks like on the left, on the right, without even using any notation, you could just simply tell me that, well, on the left, it's going down, looks like it's decreasing. On the right, it's going up, it's increasing. So on the right, it's going up, on the left, it's going down. But again, as I said earlier, I think the trickiest part is honestly just writing the notation for your answer. So on the left side, so that's the side that's described as x is going towards negative infinity, because this is the x-axis and it's going towards negative infinity. So on the left, it's going down. So I would say x approaches negative infinity. It's going down, so I would say that f of x is going towards negative infinity. And then instead of describing it as what's happening on the right, I'm going to describe what's happening as x goes towards positive infinity. And it's going up, so I would say that f of x is going towards positive infinity. And lastly, you're going to switch these two. So instead of saying as x approaches negative infinity, f of x approaches negative infinity, you're going to write f of x approaches negative infinity as x approaches negative infinity. And then f of x approaches positive infinity as x approaches positive infinity. And that's your answer. And I just wanted to show you one more tip to help you remember how to get the shape for the odd functions. So if you have an odd positive function, if you actually wanted to draw a line through it, it would pretty much have a positive slope. And if you have a negative odd function and you wanted to draw a line through it, it would have a negative slope. So that's a way to help you remember the shape and which way the arrows go on the left and the right.